Hello, and today we're going to be talking about graphing quadratics in turning point form. So you all know the general form a x squared plus bx plus c. This is the general form here, and we've been told to factorize this and then do the steps to graph it. But this new way puts it into this form, the a lots of x minus h squared plus k equals y. When you have an equation like this, it's somewhat easier to graph than in the general form. So, right, so here's something in turning point form. So one of the advantages of turning point form is that you can find the turning point really quickly. All you have to do, so turning point, get the opposite of whatever's in this bracket here. So I have -2, I'm going to have +2, and that's your x value. And then you just take whatever your k value is, and that's your y value. So already you've got a point just by looking at this form. Here's 2, 2. It's also fairly easy to get the y-intercept. You set x to equal 0, so sub x equals 0 into equation 1. So we get 2 lots of 0 minus 2 squared plus 2. This will become minus 2 squared. Minus 2 squared is just 4. So 4 times 2 plus 2. That will become 8 and then 10. So wherever 10 is, let's say 10's up here, there's my x value. And then you can sort of curve it up and make the graph like that. But what if it was something like a minus instead? Yeah, if that was the case, we'll get it in the negatives. So our turning point will become the -2. So here's -2, and it will be 2 in the x direction here. I can then solve for it again. So -2 squared is going to be 4. 4 times 2 is 8. Minus 2 is going to be 6. So find wherever the 6 is. That's 2, 6 up here. And then you can put this into the normal factorized form to get the x-intercepts. So what I'm going to do is I'm going to divide by 2. Just like this, because I know trick. So that's it in factorized form. So we can get it into +3 here and 1 here, here. Give it up. It's in the. So what did I just do here? So what I've done is that I've realized that because this is a minus out here, I can actually put it back into the bracket by realizing that this is a difference of 2 squares type of thing. You have a plus b instead of a minus b. That's going to become a squared minus b squared. So when we had x minus 2 squared minus 1, I saw that as a squared. This is 1 squared. And because of that, I can realize that because it takes this form here, I can put x minus 2 brackets, and then I can subtract 1, and then put it in another bracket here and add 1. So when I do this, I can just remove the brackets since they don't on the inside, because they don't actually do anything. So it will become x minus 2 minus 1, which is minus 3. And then x minus 2 plus 1 is going to become x minus 1. And if you expand it, we should get whatever this is. You can check this as much as you want, it will work every time, as long as this squared value here is a minus, right? Otherwise this breaks. But if it was positive, it would be above the x-axis anyway, so there isn't a point. How do we get from a normal equation like this into turning point form? So what we have to realize is that this is a method called completing the square. So we have a square, and we have an x here and an x here, and that will form an x squared. And then we're going to halve b to try and make it as much of a square. So this will be 2, and this will be 2. And what we end up having is this empty space here, this empty space. So this empty space is what we're trying to solve for. This empty space here is always b over 2 squared. Why? Well, if you think about it, if I have x plus 2 here and here, that's b halved. When I square it, I'm going to get a constant value, which is going to be b over 2 squared. All I have to do is solve for this value here. So let's do it with our example. So I want to put it into some sort of perfect square, so I need to halve b, which is going to make it 2, and then I have to square it, so that will become 4. But I can't just add 4 out of nothing. I'm going to have to subtract 4 to make sure that it stays equivalent, and then add the 2, the constants 2. What I sometimes like to do is put brackets around to know what is the perfect square and differentiate the two. I now factor this to become x plus 2 squared, and this will be minus 4 plus 2. Minus 4 and plus 2 cancel down to just minus 2, and we've got it into the form. We have x plus 2 squared minus 2. And that is the same as this. Now, if you want to put this into the factorized form, you're going to have to square root 2 and put it in. So it will be x plus 2 minus square root of 2 times x plus 2 plus the square root of 2. If you expand this, you will find that it will come out as this. So that's all the time that I have for